In this video, I'm going to go over adding and subtracting rational numbers. Rational numbers, just as a review, is just saying that we are either working with fractions, which is the same as ratios, and we also know that fractions can be written as decimals. So our rational numbers are basically just adding and subtracting with fractions and decimals, but we're also going to be working with positive and negative numbers. So if you remember back to when we were talking about integers, we know that any subtraction problem is just the same as adding the opposite. In other words, it's the additive inverse property. So as an example, if we have 7 minus 4, we know that's 3, but this subtraction problem can also be written as 7 plus the opposite of 4, which is negative 4. And if you add 7 and negative 4, you would still get 3. Another example would be negative 26 minus negative 7. Well, instead of having a subtraction problem with two negatives, we could rewrite this as an addition problem as negative 26 plus the opposite of negative 7, which would just be 7. Now, when we are solving addition and subtraction problems with rational numbers, these steps below really kind of help us work through the problems. So the first thing that you want to take note of is that we want to rewrite the problem as an addition problem if needed. And what I mean by if needed is that if it's already an addition problem, you don't need to rewrite it. But if it's a subtraction problem, we want to rewrite that as an addition problem so we can use the rules that we know about positive and negative numbers with addition. And that is nothing new. That is something we've been doing with integers. Now, after you rewrite your problem as an addition problem, you're going to look at the signs of your numbers. We're going to look and see, do we have opposite signs, meaning that we have a negative and a positive? Or do we have same signs, meaning both negative or both positive? Different things are going to happen here depending on if we have opposite signs or if the signs are the same. So when we have opposite signs, we are going to subtract using absolute value. Now, this sounds somewhat confusing because I had just told you that we're rewriting all of the problems as addition problems. But what we're going to do is subtract using absolute value if we have opposite signs. This will make more sense when we do some problems together. Now, if they are the same signs, the good news is we just continue to add using absolute value. And then we'll talk about the signs when we get down here to step 3. So if the signs were opposite, we need to use the sign of the greater absolute value. If they were the same signs, we just use the common sign of the two numbers. In other words, if they were both negative, we stay negative. If they were both positive, we stay positive. So let's go ahead and do some examples together because I think this will actually help to make this a little bit more clear. So I'm going to go ahead and start with negative 4.2 plus 3.3. Well, first of all, I am adding. So that's good news because I don't have to worry about changing a subtraction operation to addition and worrying about flipping signs and doing the opposite. The other good thing is that I have a decimal plus a decimal. So I don't have a fraction in a decimal. Everything's in the same form. So now I need to ask myself, okay, I am adding a negative and I'm adding a positive. These have opposite signs. So when we have these opposite signs, that's where we have to make sure that we subtract their absolute values. So absolute value, remember, is just a distance from 0. So really what you're just trying to find is what is the distance between 4.2 and 3.3? Because the absolute value of negative 4.2 is 4.2. The absolute value of 3.3 is 3.3. When I subtract these to find the difference, or really the distance between the two numbers, I will get 0.9. And I have to remember with my decimal numbers to line up my decimals to make sure all of my place values are in line. Now the question is, Will this be a negative 0.9 or a positive negative 0.9? I'm sorry, a positive 0.9. So we need to ask ourselves, if we had a negative 4.2 absolute value and a 3.3 absolute value, which one has the greater absolute value? Well, 4.2 does, because it has a further distance from 0. It has a greater absolute value. So since that is the number with the negative is going to stay with your answer. So your answer is negative 0.9. Now, if you want to double check your sign, you can always go back to the number line. In our problem, we started with negative 4.2. And we were adding a positive 2. So we're moving this direction on the number line, but only up 3.3. That is not enough to bring us on the other side of 0 into the positive side of the number line. So your answer is still going to be negative. Now let's go ahead and take a look at some fractions. So we are going to add fractions the same we always have. We have to make sure that we have a common denominator. But the extra step this year is that we have to worry a little bit more about signs, because in this problem, we have a negative and we have a positive. So we are adding opposite signs. So these rational numbers are on opposite sides of 0. You have a number over here that is negative, and you have a number over here that is positive. So instead of having to worry about thinking about the negatives and the positives and the jumps on the number line, we can just find the distance between these 2 points using absolute value, and then we can go back in and put in our sign at the end. So again, I am adding, so I don't have to worry about changing this to an addition problem since it already is addition. The other good news is this is a fraction and this is a fraction, so we're adding together the same form. The only thing that we need to do here is we do have to change and have a common denominator, because we can't add pieces together that are not the same size. A common denominator between 14 and 17 is 14. So this negative 9/14 is just going to stay negative 9/14. But 2/7 we need to multiply by 2 in both the numerator and denominator to get an equivalent fraction of 4/14. So now I have negative 9 plus 4/14. Now from here, you could probably use what you know about integers and just say, well, if I have a negative 9 and I'm adding 4, now I have a negative 5. And that is completely fine if that is something that you see right away. But for those of you that continue to want to follow the steps, we know that if we have opposite signs that we're adding together, we're really going to subtract the absolute values. Well, the absolute value of negative 9/14 is 9/14. The absolute value of 4/14 is 4/14. So we would subtract those absolute values, and you're still going to get 5/14. And it will be negative because the greatest absolute value, or the furthest distance from 0, is the 9/14. So our answer is going to be negative 5/14. I wanted to just go ahead and do a couple of these examples with you and have it as a video to give you some extra help. But please make sure you are also doing some extra practice on your own at home, either with your IXL assignments that I've assigned you, or you can always use Khan Academy for support as well.